down here, forming that kind of like V. The base is up top with everything else, with all these like arteries and veins coming out of it, okay? That's pretty simple. The pericardial sac isn't on here. We had to remove it to actually observe the heart. I think I showed most of you it in the cat. It was that little sac covering the heart. All right, it's just tough connective tissue protecting the heart. Epicardium is the same thing as visceral pericardium on all the organs, but it's just called epicardium on the heart. It's that thin layer that goes over the heart like viscera pleura goes over all the other organs. Make sense? Cool. Myocardium. So when you open, let me actually say this first. There's a few on the outside. So you have an anterior, the forward part of the heart, and the posterior, the back side of the heart. The anterior has the pulmonary trunk and auricle on it. This is the auricle, this little flat thing here. And the pulmonary trunk is the only vessel that actually kind of goes like laterally across the heart. The rest, like the aorta, the vena cavas, the superior and inferior, kind of stick out from the top. The pulmonary trunk actually just goes right across, okay? And that's how you can tell this is the anterior side, this is the posterior side. Again, pulmonary trunk, auricle, anterior, and posterior side is the back. On the posterior side, you actually, it's on this list, it's down a little bit further. This is the coronary sinus right here, and I'll come back to that in a moment. Myocardium and endocardium. So I'm going to open this from the posterior side. So this brown stuff, this tough muscle tissue right here, that's myocardium, myo meaning muscle. Endocardium lines the atrium and ventricles. It's this smooth muscle right here, which makes sense because in the atrium and ventricles is where the blood actually flows, and we want that to be smooth. We don't want it any friction holding up that blood flow. So that's why that's endocardium and it's smooth versus the myocardium. Yes?
If you were to pin it, would you let us know that you're
Yeah, I would let you know that it's like not the left ventricle,
okay,
the actual tissue, but don't worry about that. I'll let you know. This is the interventricular septum in the middle here. I forgot to mention that on the and outside here, right here, would be the interventricular groove. Okay, and then again the interventricular septum right in the middle. Not hard. Anterior, posterior. So now on to the pathway of blood. So oxygenated blood is brought to the heart from the lungs via pulmonary veins. You won't have to know, it's on this list, but I wouldn't pin any pulmonary veins. And it flows, so you have oxygenated blood flowing from the lungs to the heart, and the heart is what pumps that oxygenated blood to the rest of the body, okay? Via these atriums and ventricles contracting, and then that causes the pumping movement, which causes blood to flow throughout the rest of the body, and then that oxygenated blood gets sent through those capillary beds and sends deoxygenated blood back through the veins to the lungs. That deoxygenated blood gets reoxygenated, and that reoxygenated blood gets sent to the heart, and the whole process just keeps going all day, every day. Cool? Makes sense? So, how does that work? So you have pulmonary veins bring the blood from the lungs into the left atrium, which is right here. It flows from the left atrium to the left ventricle, which is down here. You can tell the atriums are up top here. The ventricles are on the bottom if you need help remembering that. The ventricles are closer to the V. The heart kind of forms a V right here. Ventricles are by the V. Okay? I don't know if that, I'm sure most of you will just remember the atriums are on top, but anyways. Left ventricle to left atrium to left ventricle via the bicuspid valve, which is, this right here. This thing right here, I don't know if everybody can see. That's the bicuspid valve. It's anchored to the endocardium by chordae tendineae, and the papillary muscles are actually at the base of that chordae tendineae. So these little strings right here are chordae tendineae. The papillary muscles will be at the base of the chordae tendineae, actually anchoring this bicuspid valve. And the reason it needs to be anchored and it's held on by these chordae tendineae and those papillary muscles is so the flow of blood is unidirectional. So it goes from the left atrium to the left ventricle and doesn't backflow. We want blood flowing in one direction and one direction only, which is why we have these valves. So it will allow blood into the left ventricle from the left atrium, but won't allow blood going back into that left atrium from the left ventricle. Make sense? Cool. It'll flow. Blood will flow then from the. Blood goes from the left atrium to the left ventricle via the bicuspid valve when the left atrium contracts. So the blood will then go into the left ventricle, and same thing, contraction in the left ventricle will send the blood up through the aortic semilunar valve, which will be right about here. I'm not going to pin it on the test. You won't need to know that, but you'll need to know it for the pathway of blood. So from the left ventricle to the aorta via the aortic semilunar valve, it goes out the aorta, goes to the rest of your body. From the aorta to the arteries, arteries to the arterioles, arterioles to the capillary beds, which remember that microcirculation from like 2 weeks ago, where you guys had to do like the microcirculation, the pulmonary circulation, all that. Well, that's where the microcirculation occurs, those capillary beds. So arteries to arterioles, arterioles to capillary beds, where they have that change of from oxygenated to deoxygenated blood. From the capillary beds to the venules, venules to the veins, veins to the vena cavas. So now you have deoxygenated blood coming back from that tissue in the vena cava. If it's coming from the bottom part of your body beneath the heart, it'll come through the inferior vena cava. If it's coming from above the heart, it'll come through the superior vena cava. Everybody following me? Cool? Okay. So here are the vena cavas. This is the inferior right here. This is the superior right here. I know it's the vena cavas because when I stick my fingers in, I can feel the tips of my fingers touching. Okay? Those are the inferior and superior vena cavas. This right here, the coronary sinus, which I said I would come back to, your heart also needs blood. It also needs to it has tissue in there just like every other, and muscle just like every other part of your body. It needs to get oxygenated blood to that tissue and send deoxygenated blood back from that tissue. That all happens in the coronary sinus. That's called pulmonary circulation. Remember there was microcirculation and pulmonary circulation. Well, in that coronary sinus is where that pulmonary circulation occurs. Okay? So, deoxygenated blood from the vena cavas and from the coronary sinus will meet here, and then deoxygenated blood will flow into the right atrium. From the right atrium, it will flow into the right ventricle via the tricuspid valve, and then all this is from these atriums and ventricles contracting, of course. From the right ventricle to the, where does it go from there? From the right ventricle, it'll flow through the pulmonary semilunar valve into the,
the trunk.
Yes, from the pulmonary semilunar valve into the pulmonary trunk, from the pulmonary trunk to the lungs, and the deoxygenated blood gets reoxygenated again. And and then from the lungs back into those pulmonary veins into the left atrium through the bicuspid valve to the left ventricle through the aortic semilunar valve to the aorta to arteries, arterioles, capillary beds, venules, veins, vena cavas into the right atrium through the tricuspid valve to the right ventricle through the pulmonary semilunar valve to the pulmonary trunk to the lungs. Over and over and over again. And even though it's easier to show this moving from left to right, and one atrium contracting, sending it to the ventricle contracting, sending it to the aorta, all that stuff, it all happens simultaneously in actual real life. It's just easier to show it from left to right or right to left when you're actually teaching it, but in real life, it's all doing this at once. Okay? And that's the flow of blood. That's the heart. That's everything that you need to know.
So the way you're holding it, if you were to close it, and that'd be the back, this would be flipped, right?
Yes. This would be the posterior side. This would be the anterior side.
Okay. And the way Dr. Application explained it, she goes from the right atrium down. You just did it.
I did it backwards. Yeah. I like working from the posterior side. It's all personal preference, but it's the same flow whichever way you go. Yes.
If you would access the pathway of blood in high school, just maybe use like diagrams and be started at from without state, like
No, as long as it's the correct pathway, I don't care. I'm about to write the pathway that I just did on the board, but again, as long as you have the right answer, I wouldn't mark it wrong.
So the trunk is what side? The
The trunk is on the anterior.
anterior.
Side.
And that's the
With
auricle.
The auricle. This
And then
little flat thing looking right here, that's the auricle.
and on the other side it's the coronary sinus right
Coronary
there.
sinus and the vena cavas.
Okay. And the top, like the aorta, will we
This
have to
big one
identify
right
that? That's a big one.
Yeah,
And
the
then-
aorta is really. I'm sorry if I didn't make that clear. I should have actually mentioned that. Again, the vena cavas are right here, inferior, superior, coronary sinus. This big one right here, that's the aorta. All right, it's the biggest one. And yeah.
Cool.
Any other questions? No. Does anybody want me to run over it again? Does anybody want to come up here and see me? I don't know. I think you guys all
It's
catch
not
the gist.
facing us, that's anterior. No, it's posterior.
Yes.